So today we're going to talk about slope is important, right? We talked about positive slope, negative slope, special cases when we had zero slope or undefined slope. And today is just slope in general. And again, this hopefully is something you've seen before. You should have done slope somewhere in your long history of mathematics. So this is just a quick video on how to find the slope of a line when you have 2 points. Right, so the first example, I'm going to give it to you as a graph. Right, so I've got 2 points, -2, 3, and 1, -2. I've plotted these points on the line. Right, find the slope and explain what it tells me about the function. Alright, so here is my function f of x. I want to know what my slope is. Well, slope, remember, is my change in y over my change in x, which you can use the equation. Alright, change in y over change in y. So I'm going to use the equation and then I'm going to talk about it graphically. Right, which I kind of got my picture here where I've already got it figured out. So I've already got the picture, so you're already going to know what the changes are. But if I didn't have the picture and I just had my points, I'd plug those in. And so this would be y1x, sorry, this would be my second one, y2x2. And so I'm going to start here. Look at my y value, so my y value -2 minus my y value of 3 in the other point, and then my x value of 1 minus my x value of -2, so that's really going to be a +2, right? Negative means a plus. And so -2 minus 3 gives me a -5, and then 1 plus 2 gives me a 3, right? Slope is -5. Now that's if I'm using the formula, which again, we'll practice more with the formula. But I can also figure this out graphically, and I can use my rise and run, my change in y over my change in... And that's what my red and green arrows are indicating here. Right? If I just count from one point to the other, right, I start here and I can go to my second point. So the red indicates I'm moving down, and you count 1, 2, 3, 4, 5, and since I'm moving down, it's a -5. So my change in y is -5. And then to get over to my point, I have to move over by 1, 2, 3, and so my change in x is 3, and you can use that. Change in y over change in x, and I get the same thing, right? Change in y was -5, change in x was 3. That was my rise and my run. My rise in this case was a negative, so I went down by -5 and over by 3. Okay, what does that tell me? Well, again, just visually, the graph is decreasing. So that means f of x is decreasing, right, moving down. And I know exactly by how much. So decreasing takes care of the negative part. So when I do the by, it's the units. 5/3 of a unit per change, you can read that, in the x unit. Whatever that would be. Alright, so 5 represent, if the function was cost and x was items, it would be my function is decreasing by -5/3 of a unit per change in my items. And if you can't read that, it's f of x is decreasing by 5/3. Well, you don't put negative here. This decreasing is the negative part per unit per change in my x unit. Alright, now we're just going to practice. So we're just going to practice finding these by hand. And so the first one, again, I'm going to write it out. Change in y over change in x. You can decide which point you want to be, point 1, point 2. It doesn't matter. You should get the same answer I do. If you do the opposite points that I do, you just get the opposite. You get, where I have a negative, you have a positive, and so on. Just as long as you're consistent. The pairs should be in the same places when you subtract. So this first piece, it comes from one point, the second piece comes from one point. I always do second point, first point, but again, however you want. Alright, so first the y value, so my second y value was -1, my first y value was -8, my second x value was -5, my first x value was -2, so that means that's going to be a +2. Again, the -1 and 5 was from the same point, the 8, -2 was from the same point. If you flip those around, it's fine as long as you do it with both cases. So up top I'm going to get -9, and the bottom I'm going to get -3, and divide that out. Alright, so my function would be increasing by 3 units per change in x, right? The second one. if you'll notice here, my y values are the same. So this is going to be a special line. Right? If we write out the equation, it would be 8 minus 8 up top, and it would be negative 4 minus 7 in the bottom. So up top I get a 0, and the bottom I get negative 11. Well, you could take out your calculator, divide 0 by negative 11, and it comes out 0. So my slope is 0. So this is a special line. There is no increase, there is no decrease. It's a horizontal line or a constant function. Alright, next example. Alright, so again, change in y over change in x. I'm going to start with my y. So my second y is 1, 1 minus the first y, which is 0.6. My second x, which is negative 0.2, minus my negative, so again it's going to be a plus. And so up top, when I take 1.1 minus 0.6, so when I take $1.10 minus 60 cents, it's going to come out 50 cents. Alright, when I take 30 cents minus 20 cents, it's going to come out 10 cents. Or again, you can use your calculator. 0.5 divided by 0.1 comes out 5. Alright, so my slope is 5. So this particular function is increasing by 5 units per change in x. Alright, the last one, I believe. Again, if you look at this last one, my x values are the same, so this is a special line. Alright, if we went through it and found it, up top would be 8 minus 4, the change in y. In the bottom, though, I get negative 1 minus a negative 1, which really is negative 1 plus 1, so I would get division by 0, which means this is undefined. So this is our special vertical line, right? The vertical line, all x values have to be equal to negative 1. I didn't write that on the horizontal line, but that would be all y values equal 8, right? And so that's practicing slope. So again, if you're comfortable and good at slope, you should be good. Again, it's the same thing, change in y over change in x. That's the big part you have to remember. And we'll do more slope. Actually, we're going to interpret slope in the next set of notes. So I'm going to stop the video there.